Try that again. Independent is just like it sounds. So like if I rolled a dice 2 times in a row, okay, what's the probability of me getting a 6 and then a 5? Well, you'd have a 1 out of 6 chance of getting a 6, and then you'd also have a 1 out of 6 chance of getting a 5. So that probability would be 1 out of 36. That's independent because when I roll the second time, does what happened the first time matter? No, it has no effect on the second time, correct? All those times when, you have parents who keep having either all boys or all girls, and they're saying, well, the odds are with you. You're going to have to get the other one eventually. Not true. Okay? The odds are going to be the same every single time, right? Okay? What happened before has no effect on what happened now. That's independent. Okay? Dependent, now we start getting into this thing called conditional probability. And conditional probability deals with dependent. And so what happens the first time will affect what happens the second time. And the simplest example I could give you would be like, let's say you had, I don't care, 10 chips in a bag. And I'm making this over simple. Let's say 5 were orange, 3 were blue. I don't know why I did that. And 2 were black. And let's say I grabbed one. Let's say what's the odds, the probability of grabbing an orange one, and then I do not put it back in, and then another orange one. So if I reached in to grab an orange one, what's the chances of me reaching in and grabbing an orange one? What's the probability? What's the probability of me I have 10 chips in a bag. What's the chances of me reaching in and grabbing an orange one? How many orange ones are there? How many total chips are there? So the odds would be what? 5 out of 10, which is 1/2. That takes care of this one. Now, I am not putting that chip back in. Okay? So now I reach back in. How many chips are now left? 9. How many orange chips are now left? 4. So the chances of me grabbing 2 oranges in a row without replacement, well, 2 goes in here once, 2 goes in here twice, would be 2 out of 9. Do you understand the difference between independent and dependent? When it says without replacement, that always means dependent. Okay? It'll say something like this, then that. If you see the word then in your probability, that usually has to do with conditional probability, which has to do with dependent. So if you want to put down the key concepts on the packet 652, 653 in your note cards, go ahead and do that real quick. Okay, if you want to look at the worksheet page 654 at the top, example 4, it says, let's make sure we know cards. Before we even start, how many different suits of cards are there? There's 4, right? What are the suits? They're diamonds. There's hearts. There's what? Spades and clubs. Correct? How many diamonds are there? There's 13. How many hearts are there? How many spades? How many clubs? 13. How many total cards in a deck, not counting jokers? 52. How many of you knew that? Okay. All right. So it says 3 cards are drawn from a standard deck of cards. There's 52 cards without replacement. Find the probability of drawing a diamond, then a club, and then another diamond in that order. So the first draw, what's the chance of me drawing a diamond? How many diamonds were there? 13 out of how many? Now, I don't like to use those big numbers if they can simplify. What does that simplify to? 1/4. Okay. Now, there are no longer 52 cards in the deck because I've kept that one out. So now how many cards are in the deck? 51. And they want me to draw a club. How many clubs are still in the deck? 13. I haven't taken any out. Times. Now I've kept that one. So there's no longer 51 cards. How many cards are there? There's 50. And they want me to draw another diamond. Well, how many diamonds were now left? 12, because I kept one of them out. And I could simplify that to, what, 6 out of 25? So the odds of that happening would be multiplying all that together. So you'd have 78 on top, and that's 100 times 51. So that's the probability of that happening, and you could change that to a decimal. Okay? So, and that probably simplifies it, does even more. Okay? Because you could have went 3 goes in there twice, and 3 goes in there 17. We could have done that. 2 goes in there once, 2 goes in there twice, blah, blah, blah. Okay? So really that's it. I don't think we need 2 days for this. I think we're just going to do 15 through... Let's just do 15 through 33 odd, because it's pretty easy. This is on the 12.4 packet. Okay? And then tomorrow we'll either do packet 12.5 or we're going to do more on, we can take conditional probability deeper, and I might do that tomorrow. I haven't decided yet. Okay? So the end.